Now, the next thing that I will discuss to you is the greater surface area results to faster weathering. What does it mean by surface area? Now, I should find a piece of paper lying around here, like this one. This is a piece of paper. When you say surface area, it refers to all the surfaces of this paper exposed to the elements. Like this side here is all exposed to the elements. This side here is all exposed to the elements. Air, water vapor, everything. So it has a large surface area. But I can make the surface area of this paper smaller. And how would I do that? Anyone who knows how I can make the surface area of this paper smaller? How can I make the surface area of this paper smaller? Anyone? Yes? Rip it. If I rip it, what happens? This one is exposed. This one, this one, this one, this one. They're still exposed. Then you just have to add the two. So, anyone else? How can we decrease the surface area of this paper right here?
Crumble it up.
Say that again.
Crumble it up.
Crumple it up. Now, the thing is, it has a smaller surface area because everything else is hidden inside. So the only area exposed is this small compared to before it was this big. Do you get that? Okay? So this one is larger surface area. This one is smaller surface area. Do you get that? Okay? Now, which do you think will weather faster? One that has a smaller surface area or one that has a bigger surface area? A or B? Which will weather faster? Okay, you said? Say it aloud. B. So this is B. It will weather faster. How can we prove that? So, if I put this papers, I think I got two papers here, and imagine that this is both containing the same kind of acids. This is acid 1, acid 2, same concentration, same type of acid. Acids cause the weathering of rocks. So, let's see. Which do you think will be exposed to more acids faster? Which is wetter? A or B? A or B? Which is wetter? Which is more wet? A or B? Say it. B is more wet because it's more exposed to the acid compared to this one. If you open the inside, see that one? There is dry inside. It did not become wet. So this part here was not exposed to the acid compared to this one which all exposed to the acid. So the more area that is exposed to acid, the faster is the process of weathering. So, if you have a rock like this, so small, because everything else is in the inside, so this will weather slower. But, if you make this rock smaller into pieces, you break it, it's the same amount of rock, then weathering would be faster because more area of the rock, even inside, is now exposed. So it will weather faster. So that's the reason why we say the greater the surface area exposed, the faster is the process of weathering. Same with this illustration here, the rock that is on top of the ground breaks faster than the rock which is below the ground. This is because this part here is exposed to wind, water, and changes in temperature. Have you tried to unearth rocks? When I was young, I used to go outside, and then if I see a rock on the ground, I would pull it out. I would pull it out just to check how strong I am. I pretend like I'm Superman. So this is the rock. It's on the ground. But there is more rock at the bottom of the ground. So I will I am Superman. I can pull this rock out of the ground. But one thing that I will notice is that when I pull the rock out of the ground, the top that was exposed to air and water is more broken, is more weathered than the one at the bottom. Have you tried that? No. So, when you get a chance to go outdoors, test your strength. Okay? But do it carefully. Don't cut yourself or don't break your arm. You might try to unearth a boulder. I'm just telling you, just a small rock, okay? Not a boulder. You're not really Superman. Unless, of course, you're hiding a superpower. Okay? So, the one that is exposed is more weathered than the one that is not exposed. See, this one is so nice and neat here, but outside, it's all broken up because the outside is exposed to the elements. So, these are the factors that affect the rate of weathering. Again, they are the climate, that includes temperature changes, which is frost wedging. Frost wedging is a mechanical or physical weathering because the rock do not change. Surface area, exposing more, faster weathering. It's also a physical or mechanical weathering because the rock does not change. It just changes in size but not in composition, so it's physical. And then we have pollution, acid rain, because of the smoke that we produce from factories and automobiles. Acid rain not only break the rocks into small pieces, it also changes the composition because of the action of the acid. Thus, acid rain is a chemical weathering. Now, rock composition, I showed that to you here in this video, and you've seen that some of the rocks, some parts of the rocks were weathered and some were not. We call that differential weathering. That is also a physical weathering. Now, the action of living things, like this plant here, and the one that I showed you earlier, is a combination of the two. Root wedging is physical weathering, while the action of the carbonic acid from the tip of the root is chemical weathering. So that sums up our factors affecting the rate of weathering. To close it up, when we say weathering, it is simply the breaking of rocks. Okay.